Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see superposition theorem in this particular video. In previous videos we have seen what is Thevenin's theorem, what is maximum power transfer theorem. I would recommend you people to go and watch those videos so that you can understand the basics about how to simplify the circuit, how to kill the source, how to short circuit the voltage source, how to open circuit the current source, all those basics. In this video, we will see what is superposition theorem, the procedure to solve the superposition theorem, and we'll see problems. So we'll start with what is superposition theorem. According to superposition theorem, in any linear and bilateral network or a circuit having multiple independent sources, the response of an element will be equal to the algebraic sum of responses of that element by considering one source at a time. What does it mean? Right? In superposition theorem, irrespective of how many number of sources that is given, right, the response of any particular element will be the sum of all the sources, right, when consider one source at a time. For example, if you take this particular 20 ohm resistor, right, so if you consider this as a load resistor, or if you want to find out the current across this particular resistor, right, so the response of this particular element, this 20 ohm resistor, will be equal to the algebraic sum of both these sources. That is, first we got to consider this source and we need to find out what is the current that is flowing here, right? And then we got to consider this source and we got to find out what is the current that is flowing through this particular element, right? So the response of this element will be the algebraic sum of these two sources, right? But we have to consider one source at a time. That is superposition theorem, right? We will see the procedures about superposition theorem, but before that you have to understand, while solving superposition theorem, the very first thing is you have to consider one source at a time, and at last you need to find out the algebraic sum of the response of that particular element for all these sources, right? As I said before, first you have to consider this source and we need to find out the current, and then we have to use this particular source alone and we need to find out this current, and then we have to sum both this particular currents, right? But summation in the sense here, it's not only the addition of two currents. The first thing you have to understand is the direction of current. Let us say, for example, if you take this particular 20 ohm here, right, and if you see this voltage source, right, if you see this voltage source, it is from higher potential to lower potential. So the current will be flowing in this direction, right? So in this direction. So because of this particular source, the current will be flowing in this direction for this particular 20 ohm resistor, right? Whereas because of this source, the current will be flowing in this direction, right? So the current because of this source will be flowing in this direction. So you can see both the currents are opposite to each other. In that case, it will be the difference between the two currents, right? So the total current will be the difference between these two currents. So it is very important to understand what is the direction of current that is flowing, right? Only if you understand the direction, right, you can know which current has to be added and which current has to be subtracted, right? So as of now, you understand the direction of current is very, very important for any resistor or any load resistance, right? So now we'll see the procedures of superposition theorem. The very first step is to select one among the multiple sources, right? You will have various sources, and from that you have to select only one source at a time, right? And the second thing what you have to do is, except the selected source, you have to kill all other sources. Killing the sources we have already discussed in Thevenin's theorem and as well as in maximum power transfer theorem problems, right? Where killing the source means short circuit the voltage source and open circuit the current source. And then after doing that, you have to simplify the network, right? How to simplify the network? For that, you have to understand the basics about mesh analysis and nodal analysis. You can use any steps, right? You can use matrix method or equation method to solve that particular circuit. right? And after solving it, you will finding out the current or the voltage, right? And similarly, the same step is repeated for all the sources which is given in that particular problem. If there is two sources, you have to do the same step for two sources, and if it is three, four sources, you have to repeat the steps for all the sources, and at last you need to find out the summation of that particular current, provided you have to identify the correct direction of the current, right? And the last one is, upon obtaining respective responses of individual sources, perform the summation of all responses to get the overall voltage drop, right? So these are the very important steps. The very first thing is you have to identify one particular source, and then the second, like the after the selection of one particular source, all other sources has to be removed, right? And after removing it, you have to simplify that particular circuit, right? And the same step is repeated for all the sources, and at last you have to summation all the currents which you have identified, right? So now we'll see one particular problem so that you can clearly understand what is superposition theorem, right? So now the given question is, calculate the current through 1 ohm resistor, right? First I'll explain how to solve this problem, and then we'll see how I solved this problem in next slides, right? So what is the given question here? Calculate the current through this 1 ohm resistor, right? So we have to calculate the current across this particular 1 ohm resistor. And now we have seen here, we have two sources here, right? One is voltage source, another one is current source, right? So, and very first step in the superposition theorem, before solving it, you got to understand, right, whether the current is going to be in same direction or in opposite direction, so that you can have a clear idea whether you are going to add or subtract that particular currents, right? So we need to find out the current across this particular resistor. Now if you see this particular resistor, this particular voltage source, it is minus and plus, right? So the current will flow in this direction, right? And the current will flow in this direction in mesh because of this voltage source, right? So because of voltage source, the current will be flowing upwards in 1 ohm resistor, correct? From bottom to upwards. And because of this current source, the current will be flowing downwards, right? So across 1 ohm resistor, that is for current source I, it will be in the opposite direction. So these two currents are opposite to each other. So probably what you will do is, at last we will subtract those two values, right? This is the very first understanding you should get, right? And now we consider one source at a time, right? Now we consider only the voltage source. Now if you go to consider only the voltage source, I'll take this 2 volt, right? And I'm going to remove the current source. If I'm going to remove the current source, I have to open circuit the current source, right? So this will be 2 volt, right? And this will be 2 ohm, and this will be 2 ohm, and this will be 1 ohm. Now the very first step is, this is open circuited, so we have to consider only up to this particular resistors, right? And now what we have to do, we have to simplify it. How can we simplify the circuit? We need to find out the current across this particular resistor, right? For that we need to find out the overall current. So for that, what I can do here is, these two are series and these two are parallel connection, right? So if it is parallel connection, what we will do, right? It will be 2 into 1 divided by 2 plus 1, right? Parallel connection. We consider this as R equivalent, right? For simplifying these two resistors, this resistor and this resistor. So it will be a parallel connection, so it will be 2 by 3. So if it is 2 by 3, what is the value you will get? So we'll find it out. 2 divided by 3, it will be 0.666. So it will take it as 0.6767, right? So this resistor, by combining these two resistors, you will get 0.67. So how will I redraw this particular circuit? I will redraw the circuit like like this, right? So I'll read out this like this. So you'll have 2 ohm resistor, and this resistor has become 0.67. 0.67. So this will be 2 ohm, and this will be 2 volt. Now we can find out the total current, correct? What is the total current now? Now what is the total current? Now you can see here I is equal to I is equal to V by R, right? I is equal to V by R. So V is equal to 2 ohm, right? And R is equal to this two are series, right? So 2.67. 2 plus 0.67 will be. So what is the current value now we'll get? 2 divided by 2.67, right? So it will be 0.74. 0.74, right? Hope we understand all these things. This is the overall current. This is the overall current. But we need to find out the current across this particular 1 ohm resistor. I've already said what is that we have to calculate? We have to find out the current across this resistor because of this source, and also current across this resistor because of this particular source. Now we have obtained the total current here which is flowing, which is 0.74, which is 0.74. But what we have to find out, we need to find out the current which is across this particular resistor, which means here this 1 ohm resistor is simplified into 0.67, like these two resistors. So now we need to find out the current across this 1 ohm resistor, right? This 1 ohm resistor. So how will I find it out? I will use current division rule. I need to find out the current across 1 ohm resistor, right? So what is the current division rule? What is the current division rule? That is the total current into the opposite branch, right? So this we need to find out the current across this particular resistor. So we need to find out the we have to take the opposite branch. That is total current 0.74 into 2 divided by the total resistance. The total resistance is 2.67. 2.67. Correct? Now what is the value we will obtain? Right? Now we will calculate this. 0.74 into 2 is 1.48. 1.48 divided by 2.67. 2.67. What is the value you will get? So 1.48 divided by 2.67. So it will be 0.55 amps. It will be 0.5 amps, right? It will be 0.5 amps, right? So now the current across this 1 ohm resistor because of the voltage source is 0.55 amps. We have find out the current because of the voltage source. Clear? Right? Hope you can understand. So what we have done, we have taken this voltage source alone, we have open circuited the current source, and then I have parallel this connection. I found out the overall current, right? Overall current 0.74, and then by using current division rule, I have found out the current across this particular resistor. Clear? Right? Now again, what we have to do? We need to find out the current across this particular resistor, right? This particular resistor because of this particular source. How will I do that? Now we have to consider only this source, right? So what we have to do? I'll just erase this so that you can understand it. Now the second step is you need to find out the current across the this particular resistor because of this current source. So now I am short circuiting the voltage source. So this will be a 2 ohm resistor. This is again a 2 ohm resistor. And this is 1 ohm resistor. And I'm considering this current source. I'm considering this current source. This current source is 5 amp. And this is 1 amp, 1 ohm. This is 2 ohm. And this is 2. Right? Now we have to find out, we got to simplify this circuit. How will I simplify this circuit? You can see here, right now the current flows across this direction, right? This direction. So at this terminal, what will happen? The current will be splitted, right? So these two and this two will be parallel. These two and this two will be parallel. So how will I find out the parallel connection? How will I do that? So it will be 2 into 2 divided by 2 plus 2. 2 plus 2. It will be 4 divided by 4, right? So it will be 1 ohm. It will be 1 ohm. So these two resistors can be now simplified as 1 ohm. So how will I redraw this circuit? It will be 1 ohm and this 1 ohm and this current source. Hope you understand what we are doing, right? All I have done is I have just simplified this parallel connection and I obtained as 1. So it will be, this will be 1 ohm and this will be 1 ohm, correct? Now what we have to do, we need to find out the current across this particular resistor, right? Across this particular resistor, correct? So how will I find out the current across this particular resistor? Right, we have here we don't find out the overall current because the overall current is already given, correct? The overall current is 5 ohm. If you take voltage source where we had voltage, so we converted into overall current and then we used current division rule. But here directly we are using current source here, right? So it is 5 ohm, right? So we need to find out the current across this particular resistor. How will you do that? You will use same current division rule, right? So how will you find out current? I is equal to total current is 5 into, we need to find out the across this branch. So it will be opposite branch, right? So what is the opposite branch? That is 1 ohm. 5 into 1 divided by the total resistor. What is total resistor here? 1 plus 1, 2, right? And now, what is the value? 5 divided by 2. So it will be 2.5 amps. It will be 2.5 amps. Correct? Now, we have already, we have find out what we have find out. We have find out I1, right? Current I across this 1 ohm, right? We have find out the current across I ohm, 1 ohm because of the current source. What is it? 2.5 amp. 2.5 amp. 2.5 amp. Clear? Hope you understand. Now what we have obtained? The current across this resistor. What is the value? We have to find out, to calculate the current across 1 ohm resistor, right? So the current across this 1 ohm resistor, because of this voltage source is 0.55, and the current across this particular resistor, because of this current source is 2.5. So what is the total current? We know these two currents are opposite to each other, right? So the total current across 1 ohm resistor, it will be 0.55, which is in this direction, upward direction, plus 2.5 amp, right, which is in downward direction. So opposite each other, so we have to subtract actually. It's not summation. Even though we represent a summation, it is opposite to each other. So the total current is 2 amp, right? So 0.5 minus 2.5, right? Approximately. So it will be, total current is equal to 2 amp. Clear? Right? So this is how you have to solve this problem. So whenever superposition theorems question is given, you have to consider one source at a time, and then you simplify that circuit, find out the current, and similarly take other source, right? Like that, you have to use all the sources, and at last you have to add, right? Provided addition in the sense you have to find out the direction. If all are same direction, you can add. If it is someone is different direction, then you have to subtract, right? So now I'll explain the same problem here, how we have solved. So you can see here, calculate the current through 1 ohm resistor, right? So you need to find out the current across this particular resistor. So first we are taking the voltage source. If you're taking voltage source, we are open circuiting the current source. So simplifying these two resistor, the 0.67. So the total current is 0.75, which is nothing but V divided by total R, right? And then we need to find out the current across this particular resistor. So the total current into the opposite resistance divided by total resistance. That is current division rule, which we obtain as 0.5 amp. And similarly, we are taking the second source, which is only the 5 amp, right? Whereas 5 amp, we can directly find out the current across this particular resistor using current division rule. I have explained that before, and we obtain 2.5 amp, right? So if it is 0.5 and 2.5, but it will be in opposite direction, right? So that it will be a subtraction. So it will be the total current across this particular resistor will be 2 amps, right? So if you follow the procedure correctly, definitely you'll get the answer very easily, right, and accurately, right? So the simplification is very important. For that, you got to understand the basics about current division rule, right, and series parallel simplification, mesh analysis, all those things. So today what we have seen is we have seen what is superposition theorem, what is the procedure to solve superposition theorem problems, and we have seen one particular problem. Hope this video will be very useful for you. Thank you, my dear students.